What we're talking about today is the recomposition. So first thing, we're going just to compare between a lot of stuff in the first launch of the app. So first thing here, we're going to start with comparing between pure XML versus Compose. As you can see here, there is a test that happened between pure XML and Compose to see what is the render time and what's the performance for each one. That happened on a very old device compatible with Jetpack Compose, and this is the result here. The result here is very interesting. So as you can see here, the pure XML is the fastest one here. It's about 250 millisecond. Comparing to Compose, it's almost 1500 millisecond, which is really a high number. And when we did the same test on pure XML on composable in a debug mode versus compose release mode, the result here is that pure XML still the fastest one comparing to the compose in a debuggable mode with obfuscation or R8 disabled. This is the highest one. The composable in a release mode with also R8 disabled, still also, it's better than the debuggable one, but it's still also comparing to the pure XML, it's slowest. If we add more stuff to compare, which is R8 obfuscation, which means the obfuscation is on, the result here is that whenever we add the R8 obfuscation, it's faster than R8 in with R8 disabled, but also comparing to pure XML, it's still slower than pure XML. So here's the full comparison between all of them: Jetpack Compose, Compose in XML, Compose in Recycler View, pure XML, Compose R8 disabled, Compose debuggable R8 disabled. We will note a lot of stuff here. So first thing we're going to learn here is that R8 and debuggability make a significant difference in Jetpack Compose render time. As you can see here, if we turn on the R8, you will see that here the R8 make a significant change. If we make the release mode of the app of the Compose, this is also make a significant change here. So this is the first thing that we learned here. The second thing is the Compose within a recycler view was the slowest one, so it's not recommended at all to add a composable view inside the recycler view. XML was the faster at rendering than Compose, which is really sweet. I was totally shocked at the first time when I heard that, because I say that, okay, what is the reason of having Compose if it's slower than XML? But the important thing here is that the first launch always take longer to render than the subsequent launch for the Compose. However, in the Recompose after that, Recompose it's much faster and much it's much better than XML after that. So what we learn from here is that we really need to consider and take care of Recompose, because if we didn't do Recompose in a good way, then it's better to use XML than Compose in that case. So what is composition versus recomposition? Composition is the first rendering for composable function. Recomposition is the process of calling your composable functions again when input change. This happens when the function input change. When compose decompose based on new input, it only calls the function or lambdas that might have changed and skips the rest by skipping all functions or lambdas that don't have changed parameters. Compose can recompose efficiently. As you can see here, we have some red text here, something like again, input change, new input, might have changed, skip. All of this stuff we're going to discuss today. So what's skippable versus restartable? Skippable mean that when called during recomposition, compose is able to skip this function if all of the parameters are equal to the previous value. So compose compose know that, hey, this compose function, we don't have to recompose it again because we know for sure that everything inside this compose function is fixed and we don't have to re-render the screen again. Versus restartable, this function serves as a scope where recomposition can start from it. In other words, the function can be used as a point of entry for where compose can start re-executing for recomposition after a state change. So if we have a lot of composable functions and we have x, y, and z, x is a parent, y and d are the child, so we know that x doesn't have anything that need to change, which means that we're going to skip this one. But y and d, we might know that they have a lot of stuff that might change, so we have to recompose the screens again, or this composable functions again. So here we have two more concepts we need to know, which is immutable versus stable. Immutable indicate the type where all values of any properties will never change after object is constructed, and all methods are referentially transparent, or primitive types, strings, integer, float, etc. are considered immutable. Versus stable. Stable indicate as a type is mutable one, but the compose runtime will be notified if and when any public property or method behavior would yield different result from a previous invocation. So we talked a lot, but let's start with some examples here. Let's say that we have a data class called item that has name and title here. So here we have value for selected, which is a remember of mutable set of Boolean. Where do we change this value? We change this value from icon toggle button here. Whenever the user click on this one, we change the value and swap between on and off. Since this composable function know that everything from the item is immutable, so we don't have to re-render item details whenever selected change. So whenever the user click on this toggle, the value of the selected is going to change from true or false or vice versa. But the composable function will know that item details didn't change at all because it contains a mutable object. So it's going to skip this function from decompose, and it's going to only recompose this part. If for some reason we did something wrong, like a mistake, and we add this item as a var instead of val, unfortunately, when the user click on the toggle, this item details is going to recompose every time, which is a useless one because we didn't change this one. We just changed the toggle next to this item details. There is another thing here, which, to be honest, I don't recommend to use it, which is annotation called stable. We use this annotation stable to tell compose, hey, we know that this one is mutable, but please consider it as a stable. We're not going to change it. We need really to be very careful whenever we use a stable, because compose will trust us as we write the code, and they will know that we understand everything correctly, and we're not going to change these values, and it's not going to recompose this one, depend on what we say. So restartable function. So in the restartable function, we change the value here. This is a restartable function that we need to start. We don't need to start from above it. So it's going to start from here. So let's say that this item row inside the list of items. The list of items is not going to be changed, or it's not going to be recomposed again and it's going to start from here. This is the point of the entry here, and it's going to skip item details, and it's going to recompose icon toggle button. Any questions so far? Cool. So here we have a lot of tools that it can help us to understand if we do the recompose in a good way or there is something wrong. And it's really helpful, and it helped me a lot in the last few weeks. One is the layout inspector, which is inside Android Studio in the latest version. You can see here we have two columns. One is the number of time that the function is recomposed, and the other one is the number of time that this composable function has been skipped. Once you run the app and you start to check your layout inspector, you will understand this number and you will see if you're doing something wrong or you're doing it correct way. The other one, which is a simple way, but it's not the perfect one, is to add a log inside your composable function. Whenever it's recomposed, it's going to recall this. So it's going to show you in the log statement this message that you add in the log. The other one, which is an extension function, it's an extension that you can add, which is a compose compiler report. You can add something like this configuration in your project, and it's going to give you 3 different files. First one is a text file that contain a report on the stability of classes in this module. So it's going to give you 3 files for each module. And the second one is a composable.txt, which is a report on the startability and the skippability of the composable in this module. The third one is a CSV file for this file that you can import into a spreadsheet or processing via script or something like that, just to learn from it. An example about that, which is something like this one. This is just an example about what is the result of this file. So here, let's say that we have a function called highlighted snacks, which has an integer called index and has snakes, which is a list. We're going to understand why it's unstable here. And also we have a function, modifier, all of that stuff. Also, it contains the data classes here, and it's going to tell you which item, which variable in this data class, which is unstable, which can define the whole object as unstable. Something like this one. Everything here sounds good except this unstable set, and we will know why set also is unstable. So, practical tips to leverage smart composition here. First thing, break down composable functions. So for something like this view here, this view has text 1, text 2, text 3, all of them are not changeable a lot in the screen, but we have here this progress bar, which is something that most probably is going to be changed a lot in front of the user's eyes. For something like this example, it's better to keep all of this 3 texts in one composable function, and this 4th one in its own composable function. We can call it in the upper one. Why is that? Because if we keep all of them in one composable function, unfortunately, the whole composable function it's going to recompose instead of only the part for the progress bar. So the second one here is to use the key composable. So let's say that we have a list of items, and one of the items is only changed. How would the compose know that this is the only one that changed? We use key, and by key, compose would understand which one is changed, and it's going to recompose only this item instead of the whole list. Third one, read the state value at the lowest composable function. For example, let's say that we have something like this here. Instead of reading the state before the function, it's better to read the state in the lowest composable function here. So it's better to do something like that. Instead of indicate or define the state above the function, it's better to keep it in the same level that you really need to use. Because if we do that in upper level and it's going to change, it's going to recompose everything, because compose will understand that everything rely on this value. The first one here is to use the modifier lambda. So let's say that we have a sample like this one here. We have here y-axis, which is a variable one, which is something that change a lot. We don't need to do that in its own function, so it's going to re-render again. It's better to keep that as a function that calls something from the view model. So the view model is going to change it and it's going to call it again. The first one, which I hate it, but unfortunately, this is really one of the important things that I faced personally, is to use Kotlin X immutable function, immutable collections. If we go back here, I told you here, yes, that's it. 1 second. Yes, I told you here that this function is unstable because list is unstable, set is unstable. Unfortunately, compose define the collections as unstable, and and you have to use the Kotlin X collection instead of the Java collection in your state object. It's better if for example you use the list in your state, it's going to recompose every millisecond. So for example, if we use here list of string, which is equal list of, for the item row, this is the data class that we use as a state for a composable function. It's going to define this composable function as unstable, and then it's going to recompose every, in my opinion, as experience I had before, in 1 minute I found that it's recomposed more than 150 times. And once I changed this line from a list to persistent list, which is a Kotlin X immutable collection, it changed from 150 times to recompose to 1 time only, which is a significant change. The fourth one here, sorry, this is the fifth one, sorry, is the use pure functions. It's better to keep your function as pure as much as you can. What's pure mean? Pure mean that there is nothing inside the function can change it. Okay, can change it if you don't have something, so it can change internally. For example, if you have something like equation for cosine x, this is just an equation that doesn't have anything that can change from outside it. If you give x a number, it's going to give you the same result. And whenever you give it the same number, it's going to give you the same result. But if you have an equation which is cosine x plus random, there is nothing can give you, okay, can tell you that it's going to give you the same result every time, because it depends on something randomly. So here there is something like this function here, var count, which is a remember function of mutable set of 0. And every time you click on it, it's going to increase the number by 1. Sorry. Okay. So this is not a pure function because it's using something internally to change it, because we don't know what is the value of the count right now. To make pure, it's better to do it something like this, to send the count from the view model. And also whenever the user click on the button here, there is a function that calls the view model to increase the number by 1, and the view model is going to update the screen again. So everything comes from outside the function. So there is nothing inside the function can control it or change the value inside. Whatever we send to the function, we get the same result every time. That's it here. Any questions so far? I'm already done here.